Hello friend, my name is Parivesh Koju. Recently I'm studying computing from batch 32 in Softerica College. Today I'm gonna explain some remaining part of the solid principle. So the first principle is a Liskop substitution principle. L is just a refer to Liskop substitution principle, which is probably the most complex principle among the five principles. So it states that if a class A is a subtype of class B, we should be able to replace B with A without disputing the behavior of our program. So now moving towards the code example and explanation, assume that for a moment that some kind of code here we can see. So let's say I had a class called social media that supported all the social media activities so that user may be entertained. Social media platform like Facebook, WhatsApp, Instagram, and Twitter, among others, various types of offspring can have a multiple implantations or multiple offspring. So assume for a moment that we have a Facebook who wants to employ the features or functionality. In the 21st century, I think everyone uses the Facebook app. And since Facebook has all the capabilities mentioned above, so we can say that it completely replaces the social media class and can do so without causing any description. So now let's talk about the WhatsApp class also. So here we can see the figure about the WhatsApp extensions. In light of a published post method, WhatsApp Kit are not a replacement for parents social media. So since WhatsApp is only a messaging app and does not allow user to publish content for friends, so it doesn't adhere to LSP. Similarly, how Instagram does not support the group video call capability, we may claim that Instagram children are not the replacement for parent social media. So now the main questions arise is how can I solve this principle so that my code works by following all the rules and regulation of LSP. So moving to the solution, we creating various types of social media interface. So here we can see different type of social media interface. Now it's up. So now it's up to you so that we can see various types of interface. Now as you can see, we isolated specialized functionality into a distinct class in order to adhere to LSP. Now it's up to the implementation classes to decide which features to support. So depending on the functionality they wanted, they can utilize the appropriate interface. For instance, since Instagram does not enable video call, the implementation for that app could look something like this. Here we can see the figure 2. So uh, this is how we can implement the LSP into the code by following all the rule based on this principle. Now moving towards the next principle, interface segregation principle. I just refer to interface segregation principle. So this principle, which is comparable to the single responsibility principle, and it is the first in solid that appears to interface rather than classes. So it states that it do not force any client to implement an interface which is irrelevant to them. So as an illustration, suppose you have an interface named UPI payment that look like this. We can see your code too. So now let discuss a few UPI payments implementations such as Google Pay and eSeva. Since Google Pay support these capabilities, he can implement UPI payment directly. However, since eSeva does not support the get cash back as credit balance features, we should not compile the client to override this method by implementing UPI payment. In order to support this ISP, we can develop something like the one below because we need to separate interface based on the client needs. So now we have to create a separate interface that will deal with cashback. So from the UPI payment interface, we can now remove the get cashback as credit balance options. We can separate the interface based on the client needs. For example, if a issuer currently implements UPI payment, we won't compile him to utilize anything that compile with IPS. IPS means, sorry, ISP. So now moving toward the next principle, dependency inversion principle. These just refer to dependency inversion principle. So the principle is stated that we must use abstraction like abstract class and interface instead to concrete implementations. High level modules should not depend on low level module, but both should depend on the abstraction. So now moving towards the code explanations and explanations. Uh, an example too. So here we can see the example also. Let's consider you go to nearby stores to make an purchase and decide to pay with your card. As a result, the cashier doesn't bother you to check the type of the card. You have to given when you have to given when you use your card to make the purchase. It makes no difference whether you have provided a debit card or credit card. They will simply swipe it. This is how the cashier and you will communicate about the card processing through the abstractions. So now, in order to better grasp it, let's replace this example with some code. Let's say you have two payment options, credit card and debit card. Using these two cards, you went to the stores to make some transactions and choose to pay using a credit card. Here we can see the code also. So now if you look at this code, you can see that the shopping mall class is tightly coupled with the debit card variable. If there is a problem with the user's debit card and they want to use a credit card, they won't be able to do so because shopping mall is tightly coupled with the debit card variable. To fix this, we can remove the debit card from the constructor and inject the credit card variable. So it's a totally bad method to develop code since in order to follow the DIP means dependency inversion principle, our application needs to be designed so that any form of ATM card can be used to pay at my shopping mall so that it doesn't matter if it is a debit or a credit card. So now by implementing a bank card interface, we may like the one below. I may first simply this design idea. Now this bank card will serve as an abstraction for both debit and credit card. So now looking to the solving code of shopping mall, we can see various types of credit card and debit card where by implementing a debit card, bank card, and so here the code it is. Now that the mall is closely connected to the bank card and sort of the card may be used to make a payment without having a negative effect without a conversion of DIP exist. So here we can see all the extensions, all the method that totally follow the to follow this principle, and uh, it hence it confirm the DIP exist. So in the conclusion, letter by letter we have broken down the meaning of each principle with a quick code example that violate it. So we then saw how to fix our code and make it adhere to the solid principle. So thank you.